Hi friends, my name is Ishwan Goda sir. I am studying Srivenkateswara Engineering College. My USN is 1V23 CS 189 section Chanakya, course title Digital Design and Computer Organization, course code BCS 302, topic karnaught map. Agenda: Abstract Introduction, Purpose of using a K-map, Structure of K-map, Types of K-map, Filling of K-map, Grouping of K-map, and Disadvantages of using K-map. Abstract: In this paper, we outline the use of karnaught map in order to simplify logical expressions. The karnaught, pronounced as karnaught map, was purposed for Maurice Karnaught, a telecommunication engineer, of Bell Laboratories in 1953. Realization of expression having two or three variables is what this paper aims at. Systematic way of representing and labeling a K-map is also discussed in the paper. Further, it mentioned the properties of K-map which should be used while carrying out sum of minterms, sum of products, and product of maxterms, product of sum of logic expressions. Introduction: As digital systems become more complex, the need of efficient circuit design grows. K-maps also allows engineer and designer to quickly identify opportunities to reduce the number of gates and components needed, ultimately leading to simpler, more cost-effective, and reliable electronic systems. In this presentation, we will explore the structure and operation of K-maps, the process of grouping ones to simplify expressions, and the practical applications of this technique in digital design. By the end, you will have a clear understanding how K-maps can enhance your ability to design efficient digital circuits. What is K-map? A karnaught map is a graphical tool used in digital logic design to simplify Boolean expressions. It provides a visual representation of truth table, making it easier to identify common factors and simplify the expression. K-map. In this K-map, you can see the rows and columns, and the numbers are from it's a 4 into 4 K-map. Purpose of using K-maps: simplification of Boolean functions. K-maps allows for the systematic reduction of complex Boolean expressions by visually identifying common terms, thereby minimizing the number of variables involved. Reduction of logic gates. By simplifying Boolean functions, K-maps helps reduce the number of gates required in a circuit. This can lead to lower cost, less power consumption, and smaller physical circuit sizes. Easy visualization. K-maps provide a graphical method to visualize combinations of inputs and their corresponding outputs. This helps engineers quickly identify patterns and relationships that may not be as apparent through algebraic manipulation. Fourth one is efficient grouping. K-maps facilitate the grouping of adjacent cells contains ones. The grouping provides a straightforward enabling and identification of simplified product terms that represent the original function. Structure of K-map. Dimensions. K-maps are typically structured as grid with the number of rows and columns. Depending on the number of variables, two variables is equals to 2 into 2 grid, 4 cells will be having. 3 variables, 2 into 4 grid, 8 cells will be there. 4 variables, 4 into 4 grid, 16 cells will be there. 5 variables, 2 into 4 variable K-maps, 2 4 variable K-maps, 32 cells will be there. 6 variables, 4 4 into 4 variable K-map, 64 cells will be. Types of K-map. This is the 2 into 2 K-map, and next one is 2 into 4 K-map, and next one is 4 into 4 K-map. Filling of K-map. To fill a K-map, the output values of the Boolean functions placed in the corresponding cells. Cells are filled with 1 for midterms and 0 for max terms based on the truth table. The visual representation aids in identifying patterns for simplification. Group of Grouping of K-map size. Groups can be any size, but the number of cells in group must be a power of 1, 2, 4, 8, 16. Adjacency. Cells are considered adjacent if they share a common side. In a K-map, the top and bottom rows, as well as the left and right columns, are considered adjacent. Wrapping. Cells can wrap around the edges of K-map. For example, the top cell of a column is adjacent to the bottom cell of the same column. Grouping of K-map. In the first group, if we should group in in a two variables, and a group of three variables is wrong, and we can group for four variables also, and we can group even for group of four variables, and we can group for we can't group for a group of five variables like this, and we can we should do groups are not overlapping. This is called grouping. We can group from one end to another end, and we can group for four variables. If there are same variables, it's called as um, redundant group. Disadvantages of using a K-map: complexity for large expressions. As the number of variables increases, the size of K-map grows exponentially. This can make it difficult to visualize and manipulate the map, especially for the expressions with more than 5 or 6 variables. Limited to few variables, K-maps are most effective for expressions with up to 6 variables. Beyond that, the visual representation becomes cumbersome and less practical. Manual process. The simplification process using K-maps is largely manual, requiring the user to identify and combine appropriate group of ones. This can be time-consuming and prone to errors, especially for complex expressions. Don't care conditions. While K-maps can handle don't care conditions, it can sometimes be challenging to determine the optimal way to include them in the groups to achieve the expressions. Thanks for watching.